Okay, we're told that the estimate for the number of errors after t hours is 10 to the 6 times 2 to the minus t. Part A. We have to estimate the number of errors after 8 hours. So we're just putting or subbing in 8 for the value of t into this expression. No problem. So the expression is 10 to the 6 times 2 to the minus t. Okay, don't be intimidated by this, the 2 to the power of minus t, it's no problem. That's just the same as 10 to the 6 times negative power means 1 over the thing to that positive power, 1 over 2 to the t, okay? Which could also be written as just 10 to the 6 divided by 2 to the t. 10 to the 6 divided by 2 to the t. Okay, no problem. So after 8 hours, it's 10 to the 6 divided by 2 to the power of 8. Stick it in your calculator. That's 1,000,000 divided by 256, which is 3906.25. Now, they're asking for an estimate for the number of errors. You can't really have 0.25 of an error. You can write that as the answer, but I recommend hedging your bets. Get that down on the answer sheet, okay? And also get this down, 3906 to the nearest error. Okay? Write both of them down, hedge your bets, and then you get the marks. Because it's only an estimate after all. Okay, part B. Explain whether the number of errors ever reaches 0. Okay, let's look at our expression for the number of errors. Is it possible for that ever to be 0? This is an interesting question because you can actually write yes or no for the answer, and as long as you explain it and back it up and still get the marks. Okay, if you just write yes or no, you won't get the marks. You have to back up what you say. And you can say yes or no for the following reasons. When t gets really, really big, then the thing on the bottom, it's 2 to the power of t, gets really big, and so the whole expression gets really small. But no matter how big t is, as t approaches infinity, this thing gets really, really small, maybe 0.0000001 something, whatever. But it's never exactly 0. It's always got some tiny value, no matter how big no matter how big t gets. So, this is why you can say yes or no, because you can say no, it doesn't reach 0, because no matter how big t gets, the estimate is always non-zero, and that's fine, you'll get the marks. On the other hand, you can say yes, a number of errors do reach 0, because you can't have a fractional error or part of an error like here. You can't have 0.25 an error, and you can't have 0.0000001 of an error. So when you round that to the nearest error, you get 0 errors. So therefore, yes, the number of errors does reach 0. So you can say yes or no as long as you back it up with those reasons. That's it.